All right, get ready, because today we are taking a grand tour of our cosmic neighborhood. We're going to go from the superheated, rocky worlds right next to the sun, all the way out to the icy giants and beyond. We're about to explore the incredible, wild diversity of our solar system. So, let's get started.
But before we dive in, let's just get a little perspective here. As huge as our solar system feels to us, it's just one of over 500 systems just like it that we know of. And all of them are tucked away inside our home galaxy, the Milky Way. It really puts our little corner of the universe into context, doesn't it? So, where did all this come from? How did our solar system even come to be? Well, for that, our story has to start way back, about 4.5 billion years ago.
Picture this. It all began with this massive, ancient cloud of interstellar gas and dust just floating in space. Then gravity, as it always does, started pulling it all together, causing the cloud to collapse in on itself. This created a spinning, swirling disk of material that we call a solar nebula. And over millions of years, little clumps of stuff in that disk started colliding and sticking together, getting bigger and bigger, eventually growing into the sun, all the planets, and pretty much everything else we're about to see today.
Okay, so you see this number, 8? This represents a really fundamental connection we have with our star. See, it takes a full 8 minutes for light to travel from the sun all the way to Earth. What that means is the sunlight you're feeling on your face right now actually left the sun 8 minutes ago. It's like this built-in time delay to our very existence. Wild, right?
All right, our tour bus is fueled up and ready to go. Our very first destination is the inner solar system. This is home to the small, rocky worlds that hang out closest to the sun.
And these are what we call the terrestrial planets. The key thing to remember here is that they're solid. They're dense, rocky worlds. You could, in theory, actually stand on their surfaces. You'll also notice they have very few moons, if any at all, and definitely no rings. First up, Mercury. It's the closest planet to the sun, and it is a world of extremes. It's the smallest planet in the whole solar system. It's absolutely covered in craters, kind of like our moon, and it's flying solo. No moons of its own, just a quick, lonely little world.
Next stop, Venus. Now, it's often called Earth's twin because it's about the same size, but wow, it could not be more different. Its atmosphere is so thick and toxic that it's created this runaway greenhouse effect. This makes it the hottest planet by far. We're talking so hot that lead, the metal lead, would just melt into a puddle. Oh, and as another little quirk, it spins backwards compared to most of the other planets. And that brings us, well, it brings us home. Earth. What makes our planet so special? In a word, water. Over 70% of Earth's surface is covered by it. And that water, along with our protective atmosphere, makes this beautiful blue marble the only place in the entire universe that we know of that can support life. Our final stop in the inner system is Mars, the famous red planet. Today, it's a cold, dusty, desert world. But scientists are pretty sure that billions of years ago, it might have actually had flowing water and a much thicker atmosphere. And that's the big question, right? It's why we're so obsessed with sending rovers there, to hunt for clues of ancient rivers and maybe, just maybe, signs of ancient life. So, we visited all the inner, rocky worlds. But before we journey out to see the giants, there's this huge, kind of empty-looking space we have to cross. What in the world is out there between Mars and Jupiter?
It's the Asteroid Belt. This is this vast ring made up of millions of rocky objects all orbiting the sun. You can think of it like a giant cosmic construction site, just filled with all the leftover building materials from when the solar system was forming. All the stuff that never quite managed to pull itself together to become a planet.
Okay, we've made it through the asteroid belt, and now we are heading into the realm of the giants. And let me tell you, everything out here is on a completely different scale. And this really breaks down the two families of planets perfectly. The inner worlds we just saw, the terrestrials, are small, they're rocky, you can stand on them. But these outer worlds we're heading to, the Jovians, are a totally different beast. They are immense, they're made of gas and ice, they have no solid surface to speak of, and get this, they all have rings and tons of moons. And here they are. We start with Jupiter, the undisputed king of the solar system, with its famous Great Red Spot, a storm that's been raging for centuries. Then, of course, there's Saturn, famous for its absolutely spectacular ring system. After that, we hit the ice giants. You've got Uranus, the oddball that literally spins on its side, and finally, Neptune, the cold, distant guardian at the very edge of the planetary neighborhood.
Okay, let's just pause on Saturn for a second because this is just mind-blowing.
To give you a sense of scale, its famous rings are wide enough that you could fit them in the space between the Earth and our moon. But for all that incredible width, they are paper thin. In most places, they're barely a kilometer thick. Just incredible.
So we've passed the giant planets. You might think that's the end of the line, but our tour is not over. Not by a long shot. We're going to keep going all the way to the cold, dark, and mysterious edge of our solar system. Way out beyond Neptune, you'll find the Kuiper Belt. Think of it like a second asteroid belt, only way, way bigger. And instead of rock, it's packed with billions of icy objects. This is where a lot of comets come from, and it's also home to a bunch of dwarf planets, including the most famous one of all, Pluto.
But believe it or not, even that isn't the true end. Way beyond the Kuiper Belt lies the Oort cloud. It's not a belt. It's a massive, spherical shell of icy junk that surrounds our entire solar system like a bubble. This is it. This is considered the true edge, the final frontier, where the sun's influence finally just fades away into deep space.
Wow, we have gone from the scorching surface of Venus all the way to the absolute icy edge of the Oort cloud. So now, let's head back home and think about what makes our little spot in the universe so special. When you look back on our whole journey, you start to realize our existence is just this incredible, delicate balancing act. We have a nice, stable star giving us just the right amount of energy. We have a planet with liquid water in the perfect spot. We even have a cosmic bodyguard, Jupiter, whose massive gravity helps shield us from dangerous comets and asteroids. It's this one-of-a-kind setup that makes a home like ours even possible.
And so our grand tour is complete. But it leaves you with this one huge, fascinating question. If this is what's going on in just our one little star system, then in a galaxy with billions of other stars, what else is out there just waiting to be discovered?